Hi student. So in our previous lecture, we have learned about basic fundamentals of trigonometries. In this lecture, we will be concentrating on the graphical representation of six trigonometric functions. And for that, before going to that actual topic, let us discuss some important concepts of graphical plot. So we will cover in this lecture graphical representation of six trigonometric function. Okay. So for any graphical representation, there is a concept of independent variable and dependent variable. So what is independent variable and what is independent variable? Okay. So imagine two variables. One is x, another is y. So if there is a relation between y and x in such a way that for every change in the value of x, for every change in the value of x, value of y also changes. Value of y, if value of y also changes for every change in the value of x, then we will say y is dependent on x, and we will express that relation in mathematics by y is equals to function of x, where x is the independent variable and y is the dependent variable. What is that? Let us consider this equation. Y is equals to 2x plus 3. So if x equal to 0, we can have y equals to 3. If x equals to 1, we will have y is equals to 5. If x equals to 2, we will have y is equals to what? 7. So we can see that for each change, for every value of x, I have the different value of y. That is x equal to, for x equal to 0, I have 3. For x equals to 1, we have 5. For 2, it is 7. Consider this set of variables as a point. So let us consider this one as a point P1 and this two as a point P2 and this one point P3. So P1 will have the coordinate of 0, 3 and P2 will have the coordinate 1, 5 and P3 will have 2, 7. Okay. So if I want to plot this equation, this point, basically this point in a graph, how that will be? Let us draw the axis first. So this is y-axis and this is x-axis. We already know that. So this is positive y-axis. Okay, this is positive y-axis. So I will note this one as capital Y. This is negative y-axis, so it will be y prime, capital Y prime. This is positive x-axis, so capital X. This is origin, capital O, and this is negative x-axis, that is x prime. Consider that. So, and let us divide this x-axis in smaller parts like 1, this is 1, this is 2, this is 3, this is 4, and so on. Okay. Likewise, the y-axis, like it will be 1, 2, 3, 4, 5, 6, 7, 8, and so on. Okay. Now, if we want to plot this all these 3 points, where those 3 points will reside. So coordinate of point P1 will be is 0 and 0 comma 3. What is that? 0 means what? Here, and 3 means 1, 2, 3. So this is the point P1. Okay. And next point, that is P2, will be 1 and 5. So 1 and 5 means what? 1, 2, 3, 4, 5. Here, this point is P2. And what is P3? 2 comma 7. So this is 2, 7. This is 5 already, you know. So 6 and 7. That means here. This point is P3. So you know that for x equal to 0, the value of y equals to 3. For 1, it is 5. Between x equal to 0 and 1, there are number of points are there, and for each independent value of x that lies between 0 and 1, we can have independent value of y. Sorry, depend. We can say that, but what I can say, for each independent value of x between 0 and 1, there will be a fixed value of y in each case, and all those points will lie between point P1 and P2. P1 and P2. Similarly, for the points, those reside between the value x equal to 1 and 2, all the value of y for each and every value of x between 1 and 2 will lie between the point P2 and P3. So with that concept in mind, we can draw this line, right? It will be like this. So you can say, so the line P1, P2, P3, this is, for example, so you can say this is P4. So P1, P4, this is the straight line representing the equation y is equals to 2x plus 3. In this picture, you can see that we have plot y, that is value of y in this direction, and value of, that is this value of x, actually this direction. In any graphical representation, always independent variable should be plotted along x-axis. So and dependent variable should be plotted along y-axis. Okay. So this is the axis of independent variable, and this is the axis of dependent variable. And if this is a curve, then you can say fx, then you can say this will be y and this will be x, and this curve represent y is equals to function of x. Okay, so why I am saying all these stuffs? Okay, because we're gonna plot sine theta, cos theta, and all other 6 trigonometric functions. In our previous lecture, we have seen that for each value of theta, there is a particular value of sine theta. That means sine 0 has a value 0, sine 90 has a value 1, sine 45 has a value what? 1 by root 2. So you can see that here this theta is getting changed in each cases. Okay, and we are getting different value of y equals to sine 0 and sine 90 and sine 45 and so on. So with that consideration in mind, and the concept of independent variable and dependent variable, where in the previous case it was x as an independent variable and y was a dependent variable, and you can see for each change in value of x we have different value of y. So with that consideration in mind, we can write this equation in this format, right? That is y is equals to function of theta. Basically, this is a mathematical operator. It's a mathematical operator which actually denotes there is a relation between the value of y and theta. This is a mathematical operation known as function. Function which actually denotes that there is a relation between y and theta. Okay, so what were those values? So in this chart, we already have shown in our last lecture. Okay, so here you see that there are sets of value for sine theta and another 6 function of trigonometry for each change in the value of theta. That means if theta is for theta equal to 0, I have sine theta equal to 0. If for theta equals to pi by 6, I have sine theta equals to half, and so on. Okay, so if I want to plot this function, how will I plot this? Okay, there definitely it will be plotted in a 2D Cartesian coordinate system. So let me draw axis, that is y axis, for example, say, and here it is x axis. Okay, so this is positive, so this is positive y axis. I will write it as y, capital Y. It will be origin 0, and this is negative y axis, that is y prime, and this is positive x axis, that is capital X. So here, for the plotting of this function, we already came to know that for any function y is equals to function x, we will plot x, that is independent variable, along the x axis, and dependent variable, that is y, along the y axis. Here theta is a independent variable, and sine theta or cos theta or this tan theta or other function are y actually. Okay, so we will plot theta along the x axis, I mean here, and y, that is value of sine theta or cos theta, along the positive axis, that is y, along the positive y direction. Okay, and theta we will plot in degrees or in radian. Okay, so that means radian means what? 30 degree equals to, you can say, pi by 6 radian. 45 degree equals to pi by 4 radian, like that. Okay, and 60 degree equals to pi by 3 and 90 equals to pi by 2. So if this is y and it is value of 1, and if this is pi by 2 and this is pi and this is 3 pi by 2, and plotting the value of theta in this direction in radian format. Okay, there how the plot of sin theta will look like. So sin 0 0, sin 90 1. So it will start from 0, it will achieve the value 1 when it reaches the value 90. Again, the value of sin theta will start decreasing as soon as it crosses the value theta, and it will achieve the value 0. It will achieve the value 0 when it becomes pi. So it will be like here. Okay, again at 3 pi by 2 it will have the value minus 1. So for example, this is minus 1. Okay, so at 3 pi by 2 it will the graph will be look like this. Okay, so this is minus 1. In the similar way, if I want to plot y equals to cos theta, how that will look like? You can see cos 0 is 1. So it will start from here. At 90, the value is 0. So cos theta will start from 1. It will achieve the value 0 as soon as it reaches the value pi by 2. It will continue decreasing its value, and at pi it has the value minus 1, I mean here, and at pi by 2 it will have the value 0, and then at 2 pi it will have the value 1. That means here. Okay, so actually the graphs are very smooth. Let me draw in a graphical tool. Okay, this one. So if I want to plot y equals to sin x, how that will look like? So likewise I am saying that this is the graph of sin x. It will start with 0, it will achieve the value 1 at 90, and then again 0 at pi. In the same graph, if I want to plot the value of cos theta, that is cos x, how that will look like? So you see, the green one is a cos curve and the blue one is a sine curve, and both this curve intersect with each other here. This is pi by 4. In here, both the sine theta and cos theta has value 1 by root 2. That is why the curve looks like this. Okay. The similar way, if I want to plot tan theta and cos theta, how that will look like? Okay. So if I want to plot y is equals to tan x, so tan 0 is 0, tan 90 is equals to infinity. So it will be in an increasing order. Like it means the value increases. Okay, and doesn't have any end. Okay. Similar way, if you want to plot cot graph, so cot x, So you guys know that the sine graph and cos graph is actually reverse. You see here, tan theta, I'm getting the value in this direction, and if I want to write, basically, where is my pen? Just a second, guys. So I lost my pen. Yeah, got it. Okay, so if I want to write this function, so in this order, so it will be value of tan theta. So and cot theta value will be, we will start from here, just reverse of this. Okay, that means reverse of tan equals to cot, like that way. So tan 90, if you see tan 90, infinity. Cot 90, cot 0, infinity. This value comes here. This value comes here. This value goes here. Tan 0 goes here. So it's a reverse, right? For that, cot 0 has value what? Infinity. So it starts at infinity. And it achieves the value 1 where? At pi by 4, that is 45 degree. So both at pi by 4, both the tan graph and cot graph intersect with each other. Then again, cot 90 means what? 0. So cot 90, 0. So it comes here. So blue one is a cot x curve, and yellow one, basically orange one, is a tan x curve. In the similar way, we will have the plot of sec x, y is equals to sec x. So sec 0 means what? Sec 0, 0. Sec 0, 1. Then sec at 90 degree, sec becomes infinity. So it infinity. Okay. Again, at pi, the value of sec is minus 1. Okay. So as soon as this crosses the value pi by 2, the value of sec start increasing from the negative maximum of negative value, and it achieves the max value at of minus 1 when it reaches the value pi. So the graph will be like this. And the cosec x will be what? Y is equals to 1 upon sin x. So this is a plot of cosec x. Cosec 0. Cosec 0. That means infinity. So it starts at infinity. Cosec and sec. Cosec and sec has the same value of root 2. That is 1.414. Here. 1.414. And both the sec x and cosec x intersect with each other at pi by 4. That is at 45 degree. Okay. So this is the plot of cosec 1. The red one is the cosec x, and y one is the, that is the black one is the sec x. Okay, for fun, let me draw all the graph in a same graphical form. So let me draw y is equals to, it is very beautiful, actually. Then y is equals to cos x here, y is equals to tan x also here, y is equals to cot x also here. So it's very beautiful actually. Okay, this is the plot of all trigonometric function in a same format. Okay, so and here, from here, if you see, we have some impactful observation here. So this is pi by 4. Okay, So in pi by 4, the value of the sine theta cos theta, tan theta cot theta, sec theta cosec theta intersect each other. Likewise, we see here this curve. This one is a cos curve and this one is a blue one. Cot x curve. Both this value has 0 at pi by 2. So that's it for the today, guys. For any questions, do the comment in the video and please like, subscribe and share my channel, and just let me know for any doubt and comment in the comment box. Thank you.